committee. So they will only be giving comments on standard and they will be developing standards. So this Manak Manthan BIS started to get comments from different stakeholders all over India who are actually using the standard, and it may not be possible to involve everybody in the committee always. So we as BIS branch officers, we are trying to reach out to different people who are actually using the standard and get comments on the Indian standard. And we, in fact, deliver your comments and views on the standard to the standards formulation department, and they will be discussing and putting up to the committee, which will be further deliberated whether we need an amendment to the standard or whether standard needs any further updation on the Indian standard which we have already formulated. So I welcome you all for this Manak Manthan today. And I once again thank all the chief guests and guest of honor for honoring BIS by coming to this meeting today. Thank you so much, sir.
Thank you, madam, for the inspiring inaugural address outlining BIS standardization roadmap. And I invite Sri D. Murali Mohan Garu, Director, State Disaster Response and Fire Services AP, to share his address.
Good morning, respected madam and other stakeholders and my dear friends. See, so I have gone through this fire resistance glass code 19328 2025. The name is fire resistance glass, but there is nothing mentioned about fire. Only glass they mentioned. So glass. So what is glass? Glass is a hard, brittle, transparent or translucent material made up of silica or sand. We know all these definitions. Giving higher temperatures and cooling, that material will come as glass. Nowadays, glass is used for so many decorative items like building facades, exit corridors, lift lobbies, staircases. Staircase means side handrails. So many other things. But how much care we are taking about the fire resistance? If something goes wrong with respect to fire, how stability the glass will have and how much time it will take to burn itself. That is to be clearly defined in the code, and everybody should also understand what is the fire resistance glass and what is normal glass. But anyway, in this code, they have mentioned some classification they have mentioned. That is glass for integrity, how much resistance it will have, at what temperature it will be capable of having its own strength. Number two, integrity and radiation, how much radiation the glass will take, the temperature. Number three, integrity, radiation, and also the insulation capacity of the glass. These reclassification they were mentioned in this code. And generally we use glasses for super toughened glass, glass ceramic, borosilicate. So many things are there in IS 19328 code. These products undergo strict checks and fragmentations, thermal stability, impact resistance, radiation control, insulation procedure. But it is important for us to understand that ordinary toughened or laminated glass, no matter how strong, cannot be treated as fire resistance glass unless it is tested and certified to this standard. So this standard shall be applicable and shall be implemented by all the stakeholders whenever we are dealing with the glass structures or glass decorations. So coming to the IS code, I have pointed out brought the notice of the madam that some suggestions are missing in the code. Those are fire rated frames. So they have talked about glass, but in which frame it will be fixed? That is fire rated frames, steel or aluminum, fire rated glazing beads, fire rated gaskets, anchorage or fixing hardware like that. And in some cases, I found missing resistance against the water sprinklers, how far it is resistant, behavior under hose stream. Whenever there is a water from the hose coming, how much what is the behavior of the glass? It will resist smoke leakages, impact safety classification, resistance in humid or corrosive industrial locations, and also I found some considerations for special buildings, sloped or overhead glazings, load-bearing glazed assemblies other than general and criteria, external facades, fire performance, use in high wind load environments, fire exposure from both sides, atriums and external facades. So like this, so many points are not covered in BAS. I requested madam to include all those things. And practically when we are facing the fires in a glass facades and glass showrooms, the first thing we encountered was we have to break the glass. Whenever we will break the glass will not come to crystals. So it will go like pieces, which will hurt our fire service personnel. So that should not be the case. Whenever a glass is broken, the glass should have crystal like car glasses that should have some safety measurements for the firefighters to deal with that. So likewise, some practical approach shall be incorporated in the code, and I request all stakeholders and other officers that compliance is not only a regulatory requirement, it is a moral responsibility to safeguard human life. Just not as the IS code is document, it should be implemented in toto for the human life safety. Thank you, ma'am.
Thank you so much.
Thank you, sir, for giving me permission. We will call technical committee immediately. Now, Professor Deva Kumar Garu, kindly speak a few words.
So, good morning, all of you. On behalf of Institute of Engineers, Andhra Pradesh State Center, and Board for Community Development through Education, Government of Andhra Pradesh, and of course, on behalf of Host Bureau of Indian Standards, Vijayawada branch office, I welcome all of you for this important activity, which is titled as Manak Manthan. So, where the title itself is giving an idea about activity. So we need to do some deliberations as it is a Manthan. Right? So as different stakeholders of community are available here, from the people who are implementing this and developing the standards from BIS, and engineers and architects who are practicing at their end level, and at the same time faculty members who are delivering content on of all this technology and applications of technology, and people who are controlling fire from the fire department, and who are actually facing challenges from various spectrum are available here. So definitely, I hope this Manthan is going to give a good outcome. As already this fire resistant glass specification has been circulated to all of you. We can go through this, and we are expecting a good deliberations from all our perspectives. We are from different walks of lives. We are using engaged with the glass in the different perspectives and different applications. So definitely each one of us will be having different view on this. So basically, we need not talk much about the importance of standards and the importance of achieving sustainable development goals, but just as a recollecting amongst us, recapitulating. So our lives are being governed by standards, and quality of life is the ultimate aim for any individual and any governments in that matter of fact. So all our quality of life will be achieved through practicing of proper standards and practicing them and implementing them in every walk of our life. So United Nations has given a broad sustainable development goals list, so where we are all bound to work towards achieving them. So there is no exception as an individuals, as an organization, even as a governments. So we are bound to work to achieve these sustainable development goals. So where this present topic is also very much closely associated with that. So we are having academicians here, and we are having scholars here who are working with technology are here. So in order to have the proper education, so quality of education is one of the important activity, where we are having a set of standards for that also. We need to achieve that. And at the same time, so building a sustainable cities and communities is our SDG 11, very specifically meant for achieving the while building our cities and communities. So being we are engineers here, so we are backbones of building communities and cities. So we are having the onus on us to make them smarter and sustainable. So in recent days, there is a lot of development of building materials are taking place. So usage of glass is becoming a inevitable and essential part of our construction of buildings, or using in your industrial applications and using in other areas of our walks of life. So ultimately, all engineers will be behind the designs of all these things, and using of all this glass material, and ultimately using at end user level also. So when we are using this glass as a material, maybe it is for the purpose of aesthetics, or maybe for the purpose of intended application, and for the purpose of decoration, and for the purpose of any components which are being used at various research levels. So it is very essential to have a proper commodity for our application. So fire resistance is very much essential at many places of application. We are especially our region is susceptible to high temperatures in this environment also. So slowly the temperature levels are increasing. So when we are thinking about this environment and increased temperatures, when we are using this at the buildings, definitely we should have a proper care to avoid further unwarranted situations which are going to take place, which may lead for accidents, which may lead for any other fatal incidents. So this we have to read as engineers, read between the lines of this code, and we can suggest what are the required conditions during our applications of using this glass during our practice of engineering. And at the same time, as a citizens also, we should be aware of these standards where we can verify while taking services from people who are installing wire or glass related equipment and tools or components in our applications. And as a academicians, we should work towards the giving a proper awareness to the next generation. So students are going to be the next leaders and generation in the next generation, next leaders. So they should also have proper awareness on this. So altogether, I expect this Manthan, Manak Manthan program give a good deliberations from all of us, and I request all of you to participate in the next sessions where we are going to conduct open forum. We will like to hear from you, and that will be communicated to the proper bodies where that can be discussed at a higher level, whether there is a necessity of what type of components we as end users we are expecting, what type of specifications we would like to have, and what type of services out of this product what we'll get. All this can be discussed in this Manthan program. So on behalf of Institute of Engineers, Andhra Pradesh State Center, I take this as a good opportunity for all our engineers to share, to give our contributions as a discussions and as a feedback on this code, and at the same time we can contribute further in future also to get associated with the activities of Bureau of Indian Standards, and where we can develop further the standards. Ultimately, we can make it a standardized living for all of us, and ultimately we can contribute to our government of India also for coming out with revised and proper upgraded codes, which are ultimately need for achieving all our sustainable development goals. So with this note, I once again thank Director Garu, BS Director Garu, for giving the opportunity for all the Institutes of Engineers and Board for Community Development and Education for taking part in these deliberations. And definitely in the future, we from Institutes of Engineers and Board for Development will take part in the activities of BIS to make strengthen the codes and ultimately the quality life of our citizens of India. Thank you. Thank you for all.
Thank you, sir. BA Standard Spotlight. I invite Sri D. Vijayawada Reddy Garu, Deputy Director, to present BA's overview.
Good morning to all the dignitaries and my fellow colleagues. Thank you all for coming to this program, which is a discussion on IS 19328 fire resistant glass specification. Before starting this technical discussion, I want to give a short presentation on the overview of BIS and what activities Bureau of Indian Standards is doing in this country. Let me present you with a small presentation. So, coming to the background of Bureau of Indian Standards, Bureau of Indian Standards was first started in 1947. I'm glad to inform that Institute of Engineers India is a body which has constituted Bureau of Indian Standards draft, which in 1947. So Institute of Engineers India is the one which drafted the constitution for BIS. In 1947, the body was formed as Indian Standards Institute, which is ISI. Later in 1986, BIS got its statutory status and it is recognized as a statutory body with the following BIS Act 1986. Later in 2016, BIS was made national standards body. Additional responsibilities of promotion of standards and enforcement of standards was given to BIS. Right now, BIS is following BIS Act 2016, and according to which we are doing our duties. BIS has for conformity assessment, that is for certification purposes. BIS follows CA regulations 2018, and for hallmarking regulations, BIS follows hallmarking regulations 2018. So our presence is in throughout the country. We have around 38 branch offices, and BS Vijayawada is one of the branch which is located in Andhra Pradesh. So we have 38 branches. We have 8 own laboratories where testing of products takes place, and BIS has its headquarters centered in Manak Bhavan in Delhi. So BIS is a statutory body working under Ministry of Consumer Affairs, Government of India. So the main activities of BIS, Bureau of Indian Standards, is standardization, conformity assessment, laboratory activities, hallmarking, and training activity. So first activity, as we discussed, Bureau of Indian Standards as a national standards body has a duty to make standards for different types of products. So we have 17 division councils. In these 17 departments, we make relevant standards. Mainly, you can see IUS department, chemical engineering department, civil engineering department, so on. So in total we have around 23,875 standards made till today, and every year approximately 1,000 standards are being made by our technical committees for different types of products and are being used by the country. So this is the what I say, this is the body of a technical committee. So whenever Indian Standards Institute, that is National Standard Body of India, so BIS is the only organization which can publish national standards like Indian standards. So in order to make this Indian standards, BIS need to have a committee which has an experts from all the fields. So we have technical committees in the 17 different division councils, and each technical committee has all the members as displayed in the video. So we have a senior most member in that specific sector as a chairman, and we include industrial associations, manufacturers, professional bodies, laboratories, R&D sectors, other government bodies, state government, central government bodies, even consumer organizations and public sector units as a technical committee members. So even we include MSME, small scale and large scale industries. So these are the parts of a technical committee, and these members together they discuss standards for different types of product, and then based on the consensus approach, we will be publishing the Indian standards. We will take interest of all the different stakeholders to formulate the Indian standard, and it is in a transparent way. So the process of standard formulation involves 6 to 9 months of where work item proposal will be considered, and based on the importance, working draft will be prepared by the technical committee, and then after finalizing the preliminary draft, a wide circulation draft will be posted in the website for each standard. So why we host this wide circulation draft is to take the comments from relevant stakeholders of the country, and even other countries also can comment on this wide circulation draft. We will be hosting in our website for 2 months as a wide circulation draft. During that stage, after receiving all the comments, again a technical committee meeting will happen, and then we will finalize the Indian standard. So this is how the standards are being formulated in India. So BIS as a body, it has also given the duty of WTO TBT inquiry body. So as India signed WTO agreement, we are bound to make standards in a certain way as per WTO TBT code. So that is what we are following to make the national standards. And why these national standards are important? Because government can make any product compulsory certification from BIS. Then even foreign countries also need to get certification from BIS to send the product into India. So that is why we are hosting this wide circulation draft to get comments from all the countries regarding the standards and the technology. So that is what standardization department of BIS does. And coming to product certification department, primarily BIS product certification, which takes place in this branch offices, is voluntary in nature. So apart from this voluntary nature, based on the use and importance, our central government, government of India, is making certain products compulsory. So we are making a compulsory certification to BIS. So till now, 800 products were under compulsory certification, and we are also having foreign manufacturer certification scheme. From 2000, we have started that scheme also. So whenever a product comes under quality control order, it becomes mandatory for the companies to take certification from BIS in order to sell or store. So that is how product certification department is working to give certification to the products which are conforming to Indian standards. And then we have our compulsory registration scheme, which is for electronics and IT products like mobile phones, LED laptops, CC cameras, etc. So these electronic products are also need to be certified by BIS for making and for selling. So this is the product certification department overall information, and we are up, right now we are giving certification to approximately 1,200 different types of products, out of which 800 products are under compulsory certification. Yeah, in India, around 50,000 licenses were given to 50,000 companies for Indian standards, and for around 2,000 companies were given foreign certification. So these are the different certification marks which BIS gives to different types of products. First one is ISI mark, which you all know. It is for general products like helmet. Even if you see LPG cylinder or fire extinguisher, this ISI mark you can see, which is compulsory for a lot of daily use products. And then coming to CRS mark, it is an for electronic products. This CRS mark, which is in S shape, is given to these products which are made compulsory by Ministry of Information Technology and other ministries. Has a different procedure. That is why the mark is different, which is based on self declarations, and then surveillance will be carried out to check the conformity. And next coming, we are also certifying to management systems like quality management system ISO 9001 and food safety management system ISO 22001. So which is not only, we are not only certifying the products, we are also certifying management systems for international standards, which comes under management system certification department. And then hallmarking, which is made mandatory from 2021 for all the gold jewelry. It started in 2021. So you can see there are three marks on the jewelry there. So first is BIS logo, and next is how many carats the gold is, like 22K916, and then we have a unique 6-digit number. So these three printing is compulsory from 2021. Whenever you purchase a jewelry, it is mandatory that the jewelry should be hallmarked, and you can see these three marks on the hallmarking jewelry whenever you purchase. So this 6-digit unique number helps us to trace where the product is manufactured and where it is being sold. So this 6-digit number, if you use our BIS Care app, there is a BIS Care app which you can download from our Play Store or even Apple Store. If you type the 6-digit on the searching button, you will get to know the information: who is the manufacturer of the jewelry craft, how many carats is that gold, and who has hallmarked this jewelry. So that is how we are maintaining traceability for jewelry, gold jewelry. So mandatory standards, as discussed, primarily all the certifications of BIS are voluntary in nature. Based on the needs, company takes certification. But whenever the government feels like for public reasons, health and safety, security, infrastructure requirements, they make the certification compulsory for that products. That is by issuing quality control orders. That is how the standards are being enforced mandatory for certain important products. You can see in the picture right now, even cement, steel, transformers, even tough and glass is also mandatory, and even cooker, stove, helmet. These are all products which are daily use products and related to safety are made mandatory. Even electronic products like a printer, laptop, etc., are also mandatory to take certification from BIS. This certification is given to them after we test them in our labs. After they are following our Indian standards, we will be giving the certification to the manufacturers. So this is the second scheme apart from ISI mark scheme. This is the compulsory registration scheme, which is given to electronic and IT products. Currently, more than 77 products are under compulsory electronic scheme. If you see this symbol or the ISI mark, above there is a number which is the IS code, which is different for different products. Like today's we have fire resistant glass, which is of IS 19328. Each product has their own Indian standard, and then below we have a registration number. This registration number, or you can say the license number, is a number which can be used to know whether the license is valid license, genuine license or not. You can also search that in our website or in our BIS Care app, whether from who has manufactured it, what is the scope of the license, and where it is manufactured. You can get the information. So this is the compulsory registration scheme, which is for electronic products. So whenever a quality control orders, these quality control orders are issued by different ministries. Like if you give a quality control order related to chemicals, it is given by Ministry of Chemicals. Certain products are given by the Ministry of Commerce based on trade related issues. So these different ministries issue quality control orders, making compulsory certification by BIS, and BIS is also given an enforcement authority. So whenever there is a misuse of quality control order, like they are manufacturing something which is mandatory ISMR product without certification, that BIS has enforcement powers to seize them and also take them to court. That is how BIS is also a certification body as well as an enforcement body for different products which are published for quality control orders. So these are the general products which are under mandatory ISI mark. Coming to next system, management system certification. So BIS also gives certification to international standards for management systems. Around 17 management systems BIS gives certification for the industries, like quality management system ISO 9001. These management systems you can get certification from private bodies also, as they are international standards. BIS is also giving certification for this management system, and there are many bodies and government bodies which get certification to these systems from BIS, like even nuclear power, NPCL, NTPC. These organizations and even cement companies like Ramco, etc., they get quality management system certification from BIS. So while getting this certification, your documents, your customer feedback analysis, etc., will be checked by BIS as per international standards, and then certification will be processed. And this certification is comparatively of low cost compared to the private bodies, and it is an easy process to get this management system certification. Coming to next, laboratory department. In order to give certification, BS need to test the product as per Indian standard. Every requirement which is mentioned in the standard will be tested on the sample. So for that, BS needs its own laboratories, as well as BS also have 334 private labs which are recognized by BIS. Whenever a company applies for certification to BIS, BIS draws sample from them. They will send to our own laboratories or the private laboratories if we don't have facility. There we will get it tested as per the Indian standard. Once we get the Indian standard and after assessing their manufacturing and testing capability, we will be certifying them. So laboratory activity is also one of the part of the BIS for testing as per Indian standard. Right now, we are also giving recognition to private companies also which have NABL certification and are very interested in taking BIS recognition. Once they get to BIS recognition, our surveillance samples, our market samples, our license samples, all will be sent to them for testing purposes. Apart from giving license, apart from giving certification, BIS is also into surveillance. So every company which takes BIS certification will have to give market sample, will have to give a factory sample which will be tested regularly. So it is not a one-time certification. BIS is thoroughly is doing surveillance for the manufacturers. That is how BIS is checking the quality of the products regularly after giving certification. Coming to hallmarking, as discussed from 2021, it has made mandatory. This hallmarking of jewelry, generally the jewelers come to this assaying and hallmarking centers. These laboratories are given recognition by BIS, assaying and hallmarking centers. Every district has at least one assaying and hallmarking center, and whenever a jewelry manufacturer is going to sell his jewelry, first he will send this to assaying and hallmarking center, where it will be tested as per Indian standard, and then after getting hallmarking, it will be sent back to the jeweler, and then the jeweler will sell to the public. That is how hallmarking is taking place, and BIS is regularly monitoring this assaying and hallmarking centers through surveillance regarding how they are testing the product quality. So each carat has their own marking there, and you can check from this 6 digit also how many carats the gold is before purchasing. So this is the hallmarking department of BIS. Right now, silver is in voluntary hallmarking certification. Soon it will also become mandatory BIS certification. Right now, gold jewelry is under mandatory BIS certification. So whenever you purchase, you can see these three symbols, and you can check in online in our BIS care app what is the purity of gold instead of relying on the manufacturer. Next, coming to international activities, BIS is a foundation member of International Standard Organization (ISO) and the International Electrotechnical Commission (IEC). So BIS actively take place in meetings of ISO meetings, and also in formulation of international standards. BIS actively participates, and BIS also takes their technical committee members to these meetings to give India's view in the international standard development. So that is how actively BIS is playing its role in international standard formulation. BIS has signed MOUs with different countries also to mutually recognize the standards like Thailand, UAE, Nepal, Bhutan, Brazil, USA, etc. BIS is also actively involved in the regional cooperation under SAARC countries, where we will be also giving training to the other countries regarding standardization and other related activities. Coming to consumer protection and enforcement activities, as discussed, whenever a product comes under compulsory QCO order, BIS has the powers to seize the product if it is not BIS certified, and also BIS, whenever a public people complain to BIS that this product is not is not having ISI mark, BIS has the has the powers to go and seize the product, take as per BIS Act to the court the manufacturer who is illegally manufacturing without ISI mark. So that is enforcement activity of BIS. Even if someone is misusing ISI mark, like even if they are not having ISI mark certification, but they are printing the ISI mark, even that is a misuse of BIS Act. In that cases also, BIS can take action on the manufacturer and also seize the products. That is how BIS enforcement activities are also regularly taking place. So these are the penalties which BIS is giving for misuse of QCO, like more than minimum 2 lakhs and up to 10 times the value of gold, imprisonment of 2 years. So there are severe penalty punishments also to misuse ISI mark, hallmark, and QCO order, which is being enforced by BIS. Next, coming to compensation and redressal to consumers. This is also one of the important provision which BIS has. Even whenever you feel that an ISI mark product is not up to its quality or it's not following the standard, you can complain to BIS through our BIS Care app. There is a complaints portal. Whenever you complain, we will go for the investigation. We will thoroughly check whether the same batch is not of good quality or it is not conforming to Indian standard. If it is found that the quality of the product is not conforming to Indian standard, we will provide compensation to the customers also. We will provide the manufacturer is bound to provide compensation to the manufacturer, whether he will provide a repair or loss or pay compensation to them for the low quality product, and it BS will be mediating the redressal. Next, coming to BIS Care app. This is one of the tool which BIS has developed so that it can be used by the public regularly. This BIS Care app has many provisions. You can download it from Play Store or Apple Store. You can search ISI mark and know whether the license is operative or it is under suspension, whether it is having all the scope covered, whether it is conforming to your required standard, what is the name of the product, what is the location of the manufacturer. Every detail will be visible in the license number which is marked below ISI mark. So you can search with that license number the information in our BIS Care app. Next, BIS hallmark. As discussed, there will be a unique alphanumeric unique ID of 6-digit number on each jewelry. You can ask the jeweler if it is not visible to you. You can ask the jeweler to show it. Then he will show it through the glass, zooming glass, and you can see those magnifying glass. You can see that 6-digit number. You can type here, and you will get to know who is the jeweler manufactured it, which center has marked it, and what is the type of the material, what is the purity of the material. Everything will be, and date of hallmarking, every information will be visible to you on the gold jewelry, regarding the gold jewelry you are buying. Next, coming to registration mark, which is for electronic products. You can search whether the product is a genuine product or not. Many products which are duplicates coming from other countries like China, etc. You can check whether the product is genuine or not through this registration number. So that is how you can counterfeit all these things. Next, in this BIS Care app, you can also download the Indian standard from Know Your Standard style for all the Indian standards. All the Indian standards are free of cost. So you can download them from the BIS Care app or through the website by just logging in and creating an account. And certification related information is also provided in the BIS Care app, like what products are under compulsory certification, what products are voluntary. So you can use the BIS Care app to know all the information regarding laboratories, standards, certification, etc. also. Next, coming to training activities, BIS regularly gives training to the different manufacturers and quality persons. We have our own institute, NITS, National Institute of Training for Standardization, which is located in Noida, where we give trainings to several sectors and where we give training to different management systems, quality control persons, engineers, etc. So the calendar of NITS, every training schedule will be posted in our website, and you can apply for training and get even certification from BIS for that certain trainings. Next, imparts quality trainings in for different countries people also. Apart from that, large programs, training activities are being conducted by BIS in different branch offices, different regions also. And the recent initiatives of BIS is as a national standard body, we have started to interact with more public, like we are conducting Manak Manthan programs, which are like discussing the new standards with the relevant stakeholders, getting inputs so that our standard will be relevant to the ongoing technical technology. And then we are conducting capsule course programs for different industries. Like we are taking the quality control in charges. We are training them on site and also in laboratories how to test as per Indian standard. And quality connect, we are conducting program standard promotion activities by help with the help of students. We have created standard clubs in different schools and colleges. We are using them for these exposure visits. We are also imparting knowledge, standardization knowledge to these students by taking them to the what I say to the industries and practically showing them how standards are being followed by industries. That is how we are imparting quality consciousness in the students in the school age itself. And we are also celebrating different days like World Standards Day, BIS Foundation Day. We are calling different stakeholders, and we are celebrating the uh, quality consciousness and standardization importance. So, and also BIS is conducting state level committee meetings in every state once a year, where even cabinet secretary will be the chairman of this committee, and BIS discusses with all the secretaries and departments regarding their needs and what standards are required and how you can better utilize the standards in the government policies. And accordingly, every year, certain minutes of the meeting will be issued to all the departments to comply with the Indian standards. Recently, we can see that they are giving even tenders. ISI mark is being mentioned, which is also discussed, and they have asked all the secretaries to make mandatory of using Indian standard certified products in their tenders also. So that is how we are utilizing state level committee stage also to help standardization. And we are also creating sensitization programs to different state departments also. We are also imparting this is, for example, labor officials were invited, and they were factories officials were invited, and they were given training, 1 day training, 2 days training on the what I say quality management and standards also. That is how even we are sharing knowledge to the officers of state government. And even district level sensitization programs in each district collectorate were also being conducted, so that all the officers get to know about standards and how to use them in their day-to-day policies. And even consumer actively, we are conducting consumer awareness programs. Industry meets with certain industries of the each district were also being conducted in order to uh, promote the standardization in the local industry, so that they can make products which are complying to Indian standards and international standards. And standard clubs, as discussed, BIS Vijayawada has 300 standard clubs, and overall in India, around 10,000 standard clubs were opened by BIS to impart knowledge to the school students regarding standards and its uses. Recently, BIS is also providing concession to MSMEs, small scale and medium scale industries, women entrepreneurs for application fees and licensing fees. There is an 80% discount for micro scale industries in order to support them for application fees. And BIS, coming to BIS portals and how you can use them, there are important sectors of BIS portal. In order to download a standard, you need to go to bas.gov.in, where there is a tile called Know Your Standards tile in the middle of the website. From there, you will be directed to this page, where you can search on the name of the Indian standard or ISI mark, and the standard details will be visible to you, like who is the member secretary of the standard, which committee has formulated the standard, what is the composition of the committee, and how many licenses are there for the standard, how many laboratories are there, who all are certified for the particular standard, how many amendments have come, how many revisions have come, entire information you can get from BIS website for each standard. And you can also download the standard by clicking on the Indian standard tile. Then you will be directed to a website where you need to log in. After logging in, you will created an account. After that, you can download the standard, and also you can involve in standardization by becoming a member of a technical committee. I will show that presentation later. And if you feel that there is no Indian standard for certain product, then you can also submit a propose new standards in bis.gov.in, where you can submit what the information and all the technical specifications which need to be present in the standard. And then your inputs and your proposal will be sent to the committee, and committee based on the decision and importance, it will formulate an Indian standard, so that this standard can be widely used by all the industries. And BS also has a YouTube channel where we regularly update what's going on in BIS through Standards Watch episodes. Every month there will be, every week there will be an episode, and you can get the information regarding relevant developments in each sector also in BIS. So this is the total functioning of BIS. It has an important stakeholders from industry, academia, government departments, and consumers, and all together we work for improving the standardization levels of the country. Thank you. These are the main websites, and this is the overview of BIS. Thank you. Next, I will show you how to become a committee member of each committee, so that you can apply for that committee. And address order. Oh. Oh. Okay. So that technical committee member I will show you later. Right now, for next session.
Thank you, sir, for comprehensive and voracious talk on BS and insights. Kindly introduce yourself who are present here, please.
Introducing yourself.
Good morning to one and all. Myself, Dr. K.V. Ramana, Head of the Department of Civil Engineering from Lakredi College of Engineering, Mayalavaram.
I am Babu Rajendra Prasad, retired marine engineer, Institute of Engineering.
This is Anil Kumar Dasari, Minister of Civil Engineer, Andhra State Manager. Myself, Dr. K.S. Vivek, working as faculty in APIIC University, Civil Engineering Department.
I'm Dr. T. Sridhar Babu, HOD Civil Engineering, VVIT University.
I am Aditya, working as System Officer in Mechanical Department, BVD University.
I am Dr. C. Mahesh from VR Siddhartha Engineering College, Mechanical Department. I am Dr. Ramaya from Nagar University.
Hello, District Fire Officer, NTRT.
Myself, Srinivas Murthy, Assistant Professor, Department of Engineering.
I am Rajgopal, IGFD, Joint Director from Bureau of Indian Standards, Vijayawada branch. Myself, P. Arjun, Joint Director, Bureau of Indian Standards.
Myself, Vivek Vardhan Reddy, Deputy Director, BS Vijayawada.
Myself, Devi Ramana, Station Balatra.
My name is Markfed, Technical Department.
Good morning, my Master was asking from Institute of University. I'm a civil engineer and also a career member.
My name is T. K. Vishwanathan, and a member of the Licensed Engineers Association.
Ramanujara Rao, retired JPM, APIIC, BTC.
Thank you, sir. Now moving on, engineering academia meets 5 assistants. Dr. Ramanaya Nallagaru, Professor Mechanical Engineering, Andhra University, Visakhapatnam, and Higher Education Regulatory and Monetary Commission member for technical presentation.
Good morning, one and all. Myself, Professor Ramanaya Kallu from Mechanical Engineering Department, Andhra University. So today I am going to present on glass manufacturing standards. Standards we are considering glass. And what are the applications? You know that we are using marbles childhood. So that's we have made of the what you call glass. And nowadays, in our AP government is introducing glass bottles. So that is the second one. Now you can see the third one, different colored glasses. How we are getting the color of the glass. Then we can observe this is a bridge, glass bridge. This you may see recently in Visakhapatnam at Kailasagiri. We are opened this glass bridge. You can see the go to that one. You can see the what you call environment and all the facilities available nearby that Kailasagiri, and then this one is the construction of building with the glass doors, and even if you come to the regeneration unit, or you can go for the glass materials, and even though if you observe here, this is the stainless steel material. And what is happening inside the body, we can see. And this is a panels in an office. You can see the glass panels. It may be generally if you see behind your while entering into the room, this is the glass doors also. So these glass doors also fire resistant glass doors. So how it will be, that we will see at the end of the day. Then let us see here. This is the glass material is not a new one. It is around 6,000 years back it was manufactured. So there at the time of 4000 BC, they are using for the coating for the jewelries. At then it is next hollow glass is developed during the 1500 BC, and blowing machines. If you see the bottles, you are able to see that is no joint will be there in the bottle. That is because of the blowing process. And recently, if you observe, this is the new development, floating glass manufacturing. If you observe the manufacturing of any product, if you come to the what you call other than glass, metals. If you consider the melting of the material and pouring into desired shapes of the object. But if you consider the glass will be floating on a bed of lead. That you will see that one how it will be. So these are some of the history of glass. And let you see here what is glass. So this is one of the definition. It is an inorganic product of fusion which has cooled to a rigid condition without crystallization. So the glass material is not a crystallized material. So what do you mean by crystallization? In crystallization, the atoms are arranged in a definite pattern. All metals will exhibit the crystallized products. If you come to the non-metals, if you consider this glass is a non-metal, glass is also comes under this one. And this is one definition. So this is another thing is if you see the metals, they have a different melting points. For example, if you take a steel, it will be around 1450 to 50 degrees centigrade. If you change the carbon percentage, this may vary from the 1525 to the around 1450 degrees centigrade. In between that, change the carbon percentage, we are getting the different types of steels. Nowadays, we can see the stainless steels, plain carbon steels, medium carbon steels, high carbon steels, and high resistance materials like chrome steels. We are using these steel materials in a manufacturing of what you call. Just now, I given one example for boiler manufacturing. But if you come to the glass, it is not having a definite melting point. Why it is not having a definite melting point? We'll discuss the later slides. And this metal will be softened in a range of temperature. If you come to the crystalline materials, we have a definite melting point. After that, if you come to the lowering the temperature, it will be hard in nature. But if you come to this glass material, it will be a softness. It will exhibit for a range of temperature. So this is about a glass brief introduction, and let us come to the properties of the glass. So generally, the properties, it will be amorphous. That amorphous means it is a non-crystalline material and hard in nature. Hard in nature, why the hard in nature means hard and brittle. Once if it is a hard material, it exhibits the brittleness, so no ductility. Why it is having that one? So if you consider the on the earth, if you see the materials, it will be exhibiting in this standard. The materials will be in the form of a compounds. Compounds will be stable in form, and you may learn in the lower classes, and there will be what you call electrons will be arranged in such a way we'll have what you call we are getting the stable nature. So if you observe the iron, it will having a 3+ electrons will be needed to get a what you call forming of forming of a stable nature. We come to the oxygen, it has to giving the two electrons. If you take these two, Fe2O3, it will be stable form. That is a compound. So if the compound, if you are considering, this will be stable, but it will be brittle in nature. In such a way, the atoms are arranged in such that if you give a heat, it will be break. So that's why you are giving that name will be what do you call brittleness. So this brittleness and hard and all these things we can say in a certain standard conditions. So if you change this conditions, the behavior of the material may change. So for example, if you take the glass itself at a room temperature, it will be brittle in nature. If you increase the temperature of the material to a certain stage, after that, it will be just like a, not a liquid, it is between that. It is not a solid and it's not a liquid, it will be slurry in nature. We can get the different shape. So once if you are saying the properties, you have to mention that this is under this condition. Under these conditions, it will be hard, it will be amorphous, it will be treatable, it will not be not treatable, like that. So then the other properties is having low thermal conductivity and high electrical insulation and low coefficient of tubular expansion. Because of low thermal conductivity, expansion will be very less. It is having refractoriness. It will withstand the high temperatures. The refractoriness equality is high temperature that is a refractoriness of the material. So then absorbing colors. So the first slide I told, I have given the different colors you are getting. Not only white, we are getting the green bottles, black bottles like that, blue bottles. So the main advantage of this one is it is unaffected by air. It is unaffected by air, water, acid, or chemical reagents, except only hydrofluoride. Hydrofluoride. Remaining all any acid you can preserve it. If you you may observe while studying intermediate or below the classes or in chemistry lab, if you see all bottles and preservation of the acids, all this in the glass material only. Then high compressive strength. If you go for the tensile nature, it will not low strength, but compressive strength will be very high. So it can absorb and transmit and reflect light. So it can absorb the light and transmit the light and reflect the light. So these are some of the properties of glass. Now let us see how the glass will be. What are the products? Once if you want to manufacture the glass, we need some raw materials. So that is the first raw material. Is this one is a silica sand. This is abundantly available on the earth. So we can use the silica sand for manufacturing of the glass. Nowadays, in India also, number of the government of India also encouraging the manufacturing of glass material in place of what you call plastic materials. And then white sand or ignited flint. These are the materials. It's having rich in silica. What do you mean by silica? Silica is SiO2. This is having high refractoriness. This we are using for the manufacturing of glass. So the main drawback of this silica is the melting point will be very, very high. So this is around 750 degrees centigrade, 1750 degrees centigrade. So we are using the silica along with the other products, manufacturing of the walls of furnaces for manufacturing of steel, copper, aluminum, all these things. If you see any furnace, if you are considering either this is a what you call oil-fired furnace or electrical furnace, induction or resistance furnaces, the walls are made up of the bricks of silica sand only. Why it is so means it is having high resistance. That is a high melting point. At the same time, it is having a high refractoriness. Because of that one, we are using that one for the walls in which we are melting the material. Just like if you are consuming fooding, what we are using aluminum vessels or steel vessels. Nowadays, in golden days we are using what we call copper vessels also for fooding. Why they are using that one is the products inside will be around maximum be 110, 120 degrees centigrade only. So whatever the metals we are using, aluminum, steel or copper vessels or brass vessels, whatever it may be, those melting point will be beyond that is around copper if you are considering around 1000 degrees centigrade. So that's why we are using those materials. Similarly here, if you are melting of metals, what we have to do is and that point it has to be 10. For example, steel if you are around centigrade, so that has to hold by one vessel. That vessel will be made of silica. So that is the one. The drawback is 1750 degrees centigrade. So already metals we are melting in these vessels. In where we are melting this silica sand. So that is a question mark. So for that one, what we have to do is, in addition to this, we are using culettes. Culettes is the pieces of broken glass to increase the fusibility. So already, if you are manufacturing glass, and there will be some what they call scrap. Those things again we have to use as a raw material. Now let us see here fluxes we are using. Why we are using fluxes? For softening of this, what you call decreasing of silica sand temperature. This melting point to decrease that one. You may add these fluxes. So generally we have sodium is on flux. That is the material available. The product is Na2CO2 that you call generally soda ash. And this generally we are using sodium is for manufacturing soft glasses, and the other will be sodium nitrate and sodium sulfate also will be there. So you can get the sodium either of these soda glass or sodium nitrate or sodium sulfate, whichever is available that we can use. The second one is potassium. So this one is manufacturing of hard glass. We are using this potassium, and the potassium is getting the from what do you call potassium carbonate or potassium nitrate. Potassium nitrate. These are the in general the two fluxes. Two fluxes. Once if you add these two fluxes, the temperature of your silica sand melting point will be going down. And then if you add these two, what will happen is your glass will be very soft in nature, just filmy material. It won't have any strength. So for getting of the strength, just if you imagine our human body without your bones, your body will be what do you call just like a slurry. Just like a slurry. If you see the aged persons, 80 years, 90 years persons, it is difficult to walk because of the strength of the bone was decreased. So that's why what you have to use, we have to increase the strength by adding of stabilizers. They provide the chemical resistance. So generally we are using the calcium. The calcium where we are getting from limestone. That is, limestone is a product. From that calcium you are able to get CaCO3 or chalk or lime. That is a CaO you will get. So that increase the strength. And lead is letterage and red lead Pb3O4. Flint glass PbO you will get. And similarly zinc from zinc oxide and borates from the borax. So this boric acid we are using for heat and shock resistance of food glasses. And then we'll have the other materials, MgO, Al2O3, SRO, BaO, and ZRO. These are some of the stabilizers. How? So what I just now I said, silica is a refractory material difficult to melt, whose melting point is 750 degrees centigrade. Fluxes, particularly soda ash, are used to lower the melting point of silica. It decreases to 1550 degrees centigrade, as well as to not only that one, to limiting the melting of, you need energy. To reduce the energy and to protect the furnace structure, superstructure. Usually the structure is made up of just now I told the silica only. Then what if you add these two, we don't have any strength. And then we had to stabilizers we had to add. These are some of the stabilizers. Now if you are considering the 100%, so the 100 kg of this mixing of this glass, there is a silica and what do you call soda ash as well as calcium carbonate. If you're adding that one, we are able to get only 82.5%. That is 100 kg raw material. If you introduce, we are able to get only 82.5 kgs of glass material. Remaining will be the wastage. So now let us see here. This is the phase diagram. This we can easily understand. This one. This is what you call SiO2 is 0%. Sorry, 100% here, and it will increase the Na2O from this end to this end. This end will be Na2O is 100%. So let us see here. 100% of SiO2 is 1750 degrees centigrade. And if you come to the at a particular percentage of Na2O, we are able to get the eclectic point, that is 1550 degrees centigrade. This is a solid state. This one total solid state. So at the beginning slide, I told that I have given that there is a range of glass temperature. So if you increase the Na2O will get this is the range. This is the range. A particular range only up to here only we are able to. It is a 10 plus this side, that side we are able to get this is the range of temperature of your glass. So this is about what you call how the mixing of your materials so that you are able to get the glass. Then let us see manufacturing steps. So how we are getting the manufacturing of this glass. If you are considering these raw materials, the first one is the melting of this. The first thing is melting of this material. How you have to melt it. The second one is once if you melt it, you have to forming. What is the shape you are able to get, and what is the process you are considering for this material. Then you go annealing process. Why you need annealing process? Then we'll have a finishing. At the end of the day, you have to finish the product. We are able to, it will be looking good, and at the same time it's having strength, and it's at the same time forgetting of desired shape or not. Those things we have to get in the finishing. We are in finishing. We will have a grinding, and we will have what you call cutting of the material, and those are the things we'll see. And now let us see melting process. So in melting process, we will see this one later. Let us see here. So this is what you call, this is one technique. This is the floating process, process technique. In general, there are different methods. This is one method. So the first one is, this is the batch. Here we are the raw materials we are able to mix here. Here we are able to mix in this place. Then we have to furnace. This is the melting furnace. We are melting on 1600 degrees centigrade. So once if you melt the material, then we have to pour the material on this if you see black color, this is a lead liquid on which you are flowing the liquid glass. Then here over which you will have a blade. This blade will, if you move downward, the thickness will be decided by this blade. Once if you in this place for farming takes place, now you have to observe the temperature of your glass will be 1100 degrees centigrade at the time of pouring. Then over the farming taking place, then we will see at the end of the farming we'll get the glass temperature of 610 degrees centigrade. So here what will happen is the glass will become hard. The glass become hard to soften or any breakage of the glass. If you take the glass suddenly open to the air, the glass may break. So that's why you may go for the annealing of this process in a stepwise, 610 to 200 degrees centigrade. Increase the temperature slowly, just like annealing means furnace cooling. Like that we have to cool it. Then we have to at 200 degrees centigrade it is coming out, and at the 80 degrees centigrade we cut it the material and place the proper place. So let us see here how the batch we are considering. Let us see here. So this is the batch area where the raw materials are received and mixed and delivered to the furnace. So how it is happening? Just like that, you are not supposed to pour the raw material in the into the furnace. So what you have to do is first you have to store this material and weigh properly. Weighing is important, and proper mixing is important. Once you have to mix it and then this one is transported to the your furnace batch charger. So that is this one is the batch charger. This is the batch charger. So before that we have to do these things. This will be far away from this part, and this part and this part will be far away from your furnace. So this transportation may be taken by belt conveyors or any other bucket conveyors, whatever the feasibility or possibility is. The mass production, you may go for this conveyor belt system, or otherwise if it is a job production, so we need only a few glasses. So if that is the case, what you have to do is, if there is no need of mechanization, so properly mixing of the material in a small grinder, and then that will be transported by the buckets to the furnace. So this is about your batch. And then if you come to the furnace area, if you see the furnace area, you generally, just now I told, pot furnaces you may use crucible tanks, crucible furnaces. That is, furnace itself manufacturing the silica, and then we are holding that material, we are melting the material and pouring the molten. These are the different furnaces, and getting of heat will be different. You are getting the heat either pot furnace or crucible furnace by oil furnaces will be there. You may use the oils, and you may use the nowadays natural gases also you are using, and LPG you may use, and electrical resistance electrical furnaces or induction furnaces. These are the furnaces you may use, just like what you are using for the melting of your metals. Now let us see, come to this one. There is about this one. This already I told that float area where the ribbon is formed. So this will be just I told that this is what you call the cutting material like this, and we are adjusting this. If you see here, these are the bushes like that, and we are adjusting the thickness of this your glass, 5 mm, 6 mm, 10 mm. If you are adjusting this one, we are able to get this. This yellow one will be lead liquid metal. We call it as a lead bed. Now let us see here. Now you understand the powered raw material is proper prepare proportions are mixed with the cullet along with the cullets. That is what you call broken glass pieces. This one you call as a batch, and this is fused in the furnace high temperature maintained in 1800 degrees or 1600 degrees. It depends upon your what you call requirement. And charge melts and fuses into the viscous fluid. It looks like a viscous. It's not a fluid, fully fluid. Like if you observe the metallic materials, the fluid flows easily, but here it will not flow. It's just like a slurry. So after that one, these are the some reactions. May consider this one. This we are considering the CaCO3 and SiO2. We'll get the CaSiO3, then CO2, then Na2CO3 and SiO2, Na2 SiO3 plus CO2. So this gas will going out. This gas will also going out, and these two products again react with each other. Na2O, CaO. 6 SiO2. This is the glass. This is the glass plus CO2. So this CO2 is the most important product here. This one we have to eliminate from the glass material. Otherwise, it will be entrapped inside the material and we will get the what you call flash. So for removing that one, what you have to do is, in general, it will go out, but some of the material will be, some of the CO2 gas will be trapped. That will be removed by heating continuously till clear molten mass passes free bubbles, then cool to the 800 degrees. We can add MnO2 also. So this MnO2, any ferrous compounds are there or carbon particles are there, it will be removed. The remaining part of CO2, if it is any there, it looks like a bubbles. That bubbles will be cleared. So that will be done in the what you call farming, the farming and shaping. That farming also it's not at the room temperature. It will be shown the temperature also to get the different types of particles to desired shapes by either blowing or pressing between the rollers. The previous I given floating bed on which we are flowing the glass. So this is another method. This viscous fluid, we may pour the molds, whatever the shape of the mold, the shape of the product, that will be, we have to prepare the mold and on which we have to pour the viscous fluid. The technique we may use is the blowing technique, blowing process, or we may press between the rollers, So the best example for blowing process is our bottles. These bottles we may made up of this glass material, that is so that to reduce the internal strain in the glass. Internal strain means suddenly if you decrease the temperature, the strain will be developed, and that I already told, the glass may break. So what you have to do is anneal the glass. Annealing process you may go for, you will get the glass articles. What will happen in annealing? Cool gradually to room temperature by passing through the different chambers with descending temperature. It's not I given here just like a simple chamber, either this or this one. It is a number of chambers. You have to maintain that temperature. So you see 600 degrees centigrade is here. Out will be 200. It's not a simple stretch. There is number of chambers maintaining the different temperature. 600 degrees centigrade, 600 degrees centigrade, 550, 500, 450, like that. In that chambers, it will flow and slowly, and then we are able to get that product. Then at the end of this one farming, you will have a finishing. This is the last step in glass manufacturing. You have to clean the glasses, edges if you round it off, if you want to see that cleaning, grinding process you may use, then polishing it, and you may go for the cutting. Nowadays cutting also, we are laser cutting coming to picture. Then sandblasting. Sandblasting is one technique. We are using the sand particles to clean the surfaces of the glass. So that the sand particles are also very small in nature. Small means micron in nature, and that will be bombarded on the glass material in such a way that it won't break. Only cleaning of the surfaces. So then this is about how the manufacturing of the glass will be taking place, and if you take any glass, you will have different types of glasses. Any glass, this is the procedure. The only thing is your raw material may change. Raw material you may change. You may consider first one silicon oxide and calcium oxide. If you go for soft glass, silicon oxide and potassium oxide is the hard glass. If you want to add, suppose you have fire resistant glass, you may add some other things. If you observe this glass, whatever the glass in behind you, this glass will be a single glass. There is no layers. You may produce the layers of the glass. If you see the car front or in generally front glass if you or rear glass if you observe, the glass will not be a single glass. This will be a combination of glass. In between the layers of the glass, we are introducing some gel. That's why that will be good strength. We have a better strength. This is a fire resistant glass. Let us see here. This one, if you observe, this is IC engine. You are not able. If you see in a car also, you will have a IC engine. The 4-cylinder engine or 6-cylinder engine. If you see the nowadays, twin cylinder engines are using for the bullet. Two-wheelers. But if you come to the cars, it will be 4 or 6-cylinder engines. If you come to the lorry, it will be 12-cylinder engines. If you come to the marine, it's a ship. It will be number of cylinders will be increased. It will be around 100 or 150 like that. So what is happening inside? If you a first year engineering student the teacher may tell that inside it will be happening like this for a diesel engine cylinder. First you are compressing the air. At the end of the day, you are igniting that one is the fuel, and then because of that fuel, it will your piston will move backward. The piston is connected to the wheel will rotate. Like that we are getting the energy. Like that teacher may tell. But it is difficult to understand who is studied intermediate is not having any idea about engines, all these things. It is difficult to understand. So this, if you observe, this I have shown here only is a drastic manner. But if you see slow manner, if you observe, this one is the piston. This one is the piston. This one is connecting rod. Here will be crank. Crank is connected to this middle rod. This is on which we have fixing this wheel. This wheel is just like your car wheel. But the thing is, in the car, what will happen is you will have a gearing system and then clutch and then engine. So you will have a tire and tire to the what you call you have a gear, and then we'll have a clutch and then engine. So if you observe while starting, the vehicle will not move. So what is the meaning is there is no gear. Once if you put the gear only, you are able to move. So before putting the gear, what you have to do is you have to disintegrate between your engine as well as your vehicle. So that function is done by the clutch. So once if you move the clutch, then you put the gear, and once you release the clutch, then your vehicle will move. So similarly here, it is a direct connection. That's why the wheel is directly. There is no clutch and gear here. So if you observe, this is the piston is moving and fuel is injected inside, and you are able to get the fire. Because of the fire, energy will be released. That pushes your piston. Piston is connected to crank, connecting rod, and then crank to the what do you call your wheel. So this is the best example of this glass is fire resistant glass. So many places I have shown only one. In the many places we are using this fire resistant glasses. And let us see here, there are various standards, number of standards are there. So one is what you call fire resistant standard also. So let us see here, this is IS number title IS 2553 part 1, 2018 this one developed. This is for a safety glass. What do you mean by safety glass? How the safety glass will be there? What are the specifications? Part 1. The architectural glasses and building glasses and general uses. This standard you have to follow. This standard you have to follow. This is the 4th edition. First edition somewhere earlier than this is developed, but 2018 it was developed as the 4th edition, 4th revision. They are revising some of the additions and some the things is taken out. Then second one is IS 5437 2024. This one developed. This is a rolled glass. Rolled glass. How the patterns extra clear pattern, wide and wide pattern classes, specification, second revision. This is the second revision. So you can understand here, if you see the wide and wide pattern classes, extra clear pattern classes, you see wide and wide pattern classes means the wire is introduced between the two glass plates, glasses, just to enhance the strength of the glass, So that also how much wire we have to introduce, what is the size of the wire, and what is the where we have to place, and what is the shape of the wire. All those things will be shown in this standard. Then if you come to the ISO 5623/2012, so this is the glass determination of coefficient of mean linear thermal expansion. What is the thermal expansion of glass is given in this second revision of this standard. And then what we are discussing now is IS 16945/2008 fire resistance test of glass walls. Now, once if you see the first standard, second standard, third standard, fourth standard also, in all these cases, how the glass will be manufactured and how the shapes and where you have to use all those things as given. But how you have to test it? The testing of it is done by this standard, IS 17004/2018 testing methods for processed glass. Then this is insulating glazing unit. How the insulating of your glass material will be checked with this as per this standard. And these are about some of the standards. Then if you come to the fire resistant glass, how you give a definition, an ability to perform thermal shock, what you have seen in the video, and is capable of satisfying the appropriate fire resistance criteria for a specific period of time. Importance is the period of time. So if you observe nowadays also, if you take a vehicle and if you're running from the Visakhapatnam to Chennai, in between your vehicle you may stop somewhere else and you have taken a tiffin or food, whatever. Why you are stopping? Continuously you are not able to run. So you may think of that your engine is heated and you have to give the rest for that. So that is the time. In between this time, I have to stop your vehicle and we are running it. So so that is the time period is important. Time, how much time you are exposing your material for a particular temperature. That is important. So categories of fire resistant glasses, there are three categories. The one is ET. This glass with the characteristic of integrity. Integrity means how if your glass is exposed to fire, how the glass prevents flames and hot gases, and it does not allow the hot gases to escape from the room. For example, here the fire existed. So how your glass will be protected? This fire will be going out easily, or it will be inside. If it is you are sitting inside the room, you have to manufacture the glass. The glass has to allow if it is any firing existence here in this case. But if you come to the IC engine, so there whatever the fire is there, that fire will be inside itself. It should not be going out. If it is going out, what will happen? The energy will be lost, and whatever our function will not be working out. So then this ET glass is this one. Exposed glass prevents the flame. Hot gases, smoke, so preventing through it. Unexposed side, the maintaining the integrity. So that is the integrity. Then what is the time? How much time it will be? The flames will arrest. This is ET glass. So then if you have other one is EW glass. EW and time is important. In all the classes will be time is important. So in addition to this, the previous one, you will have a radiation. How radiation will start. So then it will be how you have to measure this one will be radiation will be 15 kilowatts per meter square measured at a distance of 1 meter. A distance of 1 meter. As usual, time is the same. And EIT, this is insulating. Integrity, radiation, and control of insulation. So these are all the, any glass if you manufacture, this will comes under this. Whatever may be the material, whatever may be the glass material, this will comes under either ET or EWT or EIT, up to now. Okay, so how this insulation, how you will find out this, if you see rising, if you see this one, if it is exposed, your glass is exposed to temperature. Now you see the total area of your glass. Anywhere it will be 140 degrees centigrade. It should not average will be 140. But if a particular place, if you observe the engine cylinder, the top, the glass top end will be exposed to every time it will be exposed to the high temperature. So there the temperature will be different. If you come to the bottom of the glass, the temperature will be different. So average temperature will be 140 degrees centigrade. But if you come to the top end, you may get the higher end. That will be maximum will be 180 degrees centigrade. Maximum 180 degrees centigrade. So this time will be the time in general while testing. What we are considering is 20 minutes, is 30 minutes, 45 minutes, 60 minutes, 90 minutes, 120 minutes, 180 minutes, 240 minutes, and around 360 minutes. These are the standard times. You may consider any one time, and you check it, and you have to note down what is the quality of your glass. Now these are the three. Now you see what you call variance. Variance means the material. If you change the material, then how it will be. So if you see the wide fire resistant glass, this is the wire. What is a steel wire you may use. It may be square shape, a rectangular shape, a round shape. It will be 0.4 to 0.6 mm. You have to place in between the glasses, and you have to observe that the edge of the glass and the where you are placing your wire will be minimum will be 1 mm. You are not supposed to put at the edge of the glass. So 1 mm you have to leave, and then you have to place your wire. Then glass ceramic fire resistant glasses. This is ceramic material you have to use. Then borosilicate fire resistant glasses. Borosilicate, boron oxide you may use. And then thermally super tough soda lime silicate fire resistant glass. So this here soda lime silicate you have to use that one for manufacturing of that. Laminated fire resistant laminations. One layer, the other layer you may place. And instruments interlayer laminated fire resistance glass and gel filled. That already I told that the car glasses we are putting the gel in between the two layers. And a low E coated fire resistant. Low E coated means E means what you call a thermal expansion very very low. So these are the different variants of glasses, different what you call different materials raw materials we are using for getting up this one. Then performance, how you will get identify the performance or characteristics of the fire resistant glasses. So first of all, you have to find the load bearing capacity of that material. How you have to find the load bearing capacity. Then the second one is to integrity. That one what I flame. If you are introducing the flame, how much time it will carry, but without failing of that. And then radiation. Then what you call insulation. These are the fire resisting ability. That is the time. What is the time? The standard time already I told that. Then let us see here load bearing capacity. So this one is given in 69. That what you call 6945. 10.4.3.1 section. They given the how we have to find the load bearing capacity. The deflection will be L by 10. If it is not exceeded this one, there is no need of that one. But we have to find the deflection, rate of deflection criteria. Let us see the if it is a flexural roads, the limited deflection will be L square by 400 mm. And if you come to the limiting the rate of deflection will be dd by L square by 9000 mm per minute. What is D and what is L? Sorry, D is the deflection. dd by dt is the, you can say this is a delta, the rate of deflection. L is the clear span of the test specimen. So what is the specimen size? That is the L. And if you come to the D is the distance from the extreme fiber of the cold design compression to the extreme fiber of the cold design tension zone of the structure in mm. So this you may consider for flexural loaded elements. If you come to that one for vertical loaded elements, limiting vertical contraction will be, this will be negative. We are able to get T is equal to H by 10 100 mm. And similarly, if you come to the what you call rate of vertical contraction, this will be 3H by 1000. H is equal to initial height. What is the height of your glass? Height of your glass. So that the diagrams are not shown here. So anyone interested, you can see the our Bureau of Indian Standard 19328. You can 16945. That standard. Then we can see that. So how you are considering samples? So once you know that the load bearing capacity, you have to do like this, and you are able to get. So how many samples you have to do it? If you come to the what you call metallic materials, tensile test. Tensile test in minimum will be 5 specimens. You have 3 specimens. You have to elongate it and fail, and we have to average of that one. Coming to the hardness, metallic materials, there also you will have different micro hardness and macro hardness. If you are considering macro hardness, it will be around 5 to 10 specimens on which the samples is sufficient. But micro hardness, it will be more than 15, 16, 16, what do you call it, size. In on sample, 16 points you have to 16 points you have to identify what is the value and average of that one you have to. Now let us see for the glass how you are doing this. So let us see here, you are considering the serial number, test parameter, testing parameter. What is the testing parameters you are considering? Thickness and what you call dimensions and squareness, end displacement, flatness. So these are all the things: thickness, dimensions, squareness, edge displacement, flatness. For all these things, 5% of the quantity from each size. Already I told that one batch you are manufacturing. From that batch, you have to take the 5%. Suppose 100 kg you are producing, out of which 5 kg of the material you have to take it out and you have to test it. Then this the size of this will be actual size of the product. What is the size you are manufacturing? That will be same size you have to consider. All samples should pass. All samples should be passed. If any one fails, again you have to take another lot and you have to do it. Otherwise, you have to reject that batch of material. That one you have to done for the thickness as well as the dimensions as well as squareness and the edge displacement and flatness. Then if you come to the fragmentation test, breaking up. So 2 specimens is important. 2 specimens is important. Each specimen will be 0.36 meter square. If you are considering square will be what you will get 0.6 to 0.6 into 0.6. That area you have to consider and you have to do it. Then next one here also the same. The 2 samples will be pass the test. Otherwise, you have to reject that lot. Similarly, resistance to shock test also the same, but the same. So the size of the sample will be changed. This is 610 mm to be 610 mm. In place of this is square material, this will be different. This also square material, but area will be different. That's edge will be here 0.61 meters, 0.61 meters. Here 0.6 into 0.6. So resistance to human impact test also the same, but the size may be different. All these have 2 specimens on. All this up to here, 4-point bending test. So 4-point bending test. So for metallic materials, we have 3-point bending test we are doing. For glass, we have to use the 4-point bend test. 2 specimens, same 360 mm by 1100. You see here, this is the rectangle. These 3 also rectangle shapes. So the previous will be square pieces. Then next, light stability test. At the beginning, I told the property of your material will be reflection of the light, absorbing of the light, like that. I told how you will stability of the light test. This will be 300 mm by 300 minimum, or otherwise bake test. So bake test also you have to do. Baking of your material. What is it is a seeping of your glass. If you observe your wood, if you place in a water, what will happen? After 2 days or 3 days, if you observe, the seeping of material taking place. But if you metallic piece, if you put it, if it is iron, there is a possibility of rusting. Otherwise, if you come to the steel, copper or aluminum, they won't rust. So that is a bake test. Similarly, boil test 3 specimens, fracture and adhesion test 3 specimens. The size may change. Suppose 500 by 500 or 300 by 300 as acceptable. Defect in the central area, any defects are there, flaws are there, any bubbles trapped inside, all these things you can, actual size of the product you have to consider. Humidity test also. These are some of the tests we may conduct. This importance is how many samples you have to consider, what is the size is. size is important. So then once if all this done and your product is ready for the packing, what is the packing rules as per the standard? Packing rules as per the standard. So there is a what you call understanding between your manufacturer and what you call purchaser. Anyhow, what you have to each packet, these information should be there. If you are purchasing a glass material, you can see that one. Indication of source of manufacturer name should be there, and the nominal thickness of the glass, and code or batch number in which batch it was manufactured, month and year of manufacturing, type of fire resistance glass. These should be important. These four should be. In addition to this, if you see the engravings on the surface of your what do you call a glass. So what is that? What is that indicates? I mean, the marking. So marking is if you see fire resistant glass with integrity. This already I told ET is marked on the your glass. Based on that one, based on the engraving, we can say this is what type of glass. 3 types of glass, na? So this is EWT or EIT, and the combination of these 3, and load bearing element. Suppose load bearing element, that material is load bearing capacity. RT also, in addition to this, RT also you have to add year of manufacturing. And in addition to all these things, the manufacturer may also put a QR code to provide additional information of the file and the file. Then BS certificate. This is important. This should be there. This should be there. So this is about glass manufacturing standard course. So this will not be there. And thank you. If you have any doubts, we can ask.
So what is the melting point of this glass?
Thank you, sir, for materials engineering expertise. Now, next is technical presentation through VC.
Good afternoon. I'm sharing my screen.
Standards virtually. Sri Tushar Jog Garu, Vertical Head Fire Resistant Glass, Ashi India Glass, and Technical Member of Chemical Department joins us through video conference for technical presentation.
Before I start, I just want to check how much time I have for this presentation, because we are already at 12:44.
Maybe you can take 15 minutes or 20 minutes.
Okay.
20 minutes.
Thank you. Before we start about understanding the standard IS 19328, we need to understand what is the fire. Fire is nothing but an chemical reaction or the combustion which is present when the 3 components of the fire is there, like an oxygen, heat, and fuel. And if we try to remove any of the component, the fire will stop. And maybe what are the causes? Am I audible?
Yes, sir. You are audible.
Yeah. The common causes of a fire could be your electric fault, accident, cooking accidents, flammable liquids, and the smoking material. How to stop this fire? There are various methods like an passive fire protection, manual fire protection, active fire protection, and detection system. In this particular standard, we are concentrating on the fire resistance glass, which come into a passive fire protection, which help to create the compartment so that the people get sufficient time during the evacuation process. So how to understand like how the other glasses, like in the last session we had understood like how the soda lime glass is being manufactured, and how this glass will behave when it exposed to the fire. If we check the ISO 834 curve, in this curve we can see the temperature is increasing rapidly during the initial phase, and then the rate of increase of the temperature is very less in the latter period. So it indicates like within the 5 minutes the temperature reaches to about 600 degrees Celsius, and in 120 minutes the temperature reaches to about 1064 degrees Celsius, where the product is being tested and evaluated. So what if we use an anneal glass which is exposed to such a high temperature? So this annealed glass will break when it exposed to about uneven temperature of 50 to 100 degrees Celsius. The laminated glass, which has the polyvinyl butyl, which is the plastic material, which will get delaminated after 250 degrees Celsius, and the glass will fall. So the purpose of maintaining the integrity will not be served. The another option is to use a tempered glass, which also get change the phase often after 600 degrees Celsius. So if you see all this kind of a glass, which is normally being used for creating the partitions in the offices or in the offices, cannot be sustain the fire temperature when it is exposed to a high temperature. So what is the solution for this part? Solution is to have a specialized fire resistance material which can help to prevent the passage of fire, smoke and gas, and it will remain as it is during the particular time limit. So what is the specialized glass are? So in the standard, we try to explain what are the different classification or category of a fire resistance glass. The first one is being the wire resistant glass, which as explained into the last session, this the wire is inbuilt during the manufacturing process of a soda lime glass of thickness, where the wire thickness is about 0.46 to the thickness is 2.56 mm of a square, and it has to be embedded about 1 mm, and the standard, like it has to follow as an IS 5437. However, the NBC 2016 say they are restricting the usage of a wire resistance glass. Then another category of an ceramic fire resistance glass. In this glass, the thermal coefficient of expansion is near to 0. That means it will not expand when it exposed to the fire. It is normally sold into an anneal form, and it shows the property of 180 minutes of fire resistance. Used for an safety as a safety glass, but it can be used for a fire resistance glass into an vision panel application. Similarly, if we go to the laminated fire resistance glass, it is a kind of a glass which can be combined with the help of a soda lime glass or a borosilicate glass can be combined to form a laminated glass. And this glass, as the borosilicate glass is also having the low coefficient of thermal expansion, it also helps to prevent, it also shows the integrity when exposed to the high temperature. Now coming to the gel fill fire resistance glass, which is a combination of two soda lime glasses, which is normally a tempered glasses, and in between that a fire resistance gel like an potassium oxide and silicon dioxide is put, and this glass when it is a finished product, it look like as clear as a soda lime glass. The thickness of a gel and the combination of a glass and gel is depend upon the how much fire resistance properties customer is looking for, and what is the fire resistance classification they are looking for. We will try to understand the fire classification in the upcoming slides. Then the next class category of a glass is an intumescent laminated glass. So this glass is similar to your laminated glass, but instead of an PVB, we put an intumescent layer which expand when it exposed to the fire. And this kind of a glass can be can be cut as per the requirement of a customer, and it can be used when the stockist or the dealers require at a site. Now let's understand the fire resistance classification. As per IS 19328, the glass is classified into three basic category: E category, EW category, and EI category. E category stands for the integrity. If you can see in this image, there is a fire on the one side and the glass partition is there, and the person is evacuating from the area. In this case, the flame, smoke and gas is not passing through the glass. However, the heat is passing through. So if you can see, the person is actually shown into a red color, which shows like sometimes this heat is so high because of the temperature. The auto ignition of the material present outside the glass on exposed area can also ignite, and it may burn the person if the temperature, the heat radiation is too high. So how to avoid it? We can go for an EI category, which can help to have the same classification, same performance as like an E category, and in addition to that, it also restricts the heat passage. So a person can easily evacuate while walking through that area. However, there is one more category which is an economical between the E and EI category, which is called as EW category. Here it has the same features as an integrity. In addition, it will also restrict the passage of a heat. So in the third case, you can see that there is no heat transfer. In the second case, there will be a heat transfer, but that heat transfer is limited to 15 kilowatt per square meter. And you can see the person can actually run through that area and safeguard their life. Now let's go into a detail of what the integrity is. So integrity, when we are checking the integrity, we are checking whether the glass is collapsing when it is exposed to the fire, whether there is an on the unexposed surface, if there is a sustained flame is coming, and if there is a gap is arising which is more than 6 mm by 150 mm, and the cotton wool pad test where we are checking like if there is any heated area. You can see in this image where there is a heated area and the cotton pad, through the cotton pad we are checking whether it is a charring, and if it is happening, it fills the integrity requirement. So this is the requirement what has been used to check the integrity of the glass. Now in EW category, we are putting the thermal radiometer at a distance of 1 meter from the unexposed surface of a glass, and where we are measuring the thermal radiation. The thermal radiation as per standard has to be below the 15 kilowatt per square meter. In EI category, we are putting the thermocouple on the surface of a door and the partition and the glass, based on the average temperature, it should not cross the average temperature of 140 degrees Celsius plus the ambient temperature, or the maximum temperature should not cross 180 degrees Celsius and the average temperature. So if this criteria, the time till which this criteria is met, we classified it for the EI classification. Now, we had a challenge when we was drafting this particular standard, like how to check the fire resistance rating, because normally the fire resistance glass is being tested into a system. However, we had came up with a procedure where there is a common platform is being created, and where the glass can be tested, and a marking, ISI marking can be put on the glass surface, where we will be checking the performance of only glass and not the fire resistance system. So the typical process of testing, it has been given into a standard where a big size of a panel and a small size of a panel is being put, and the fire performance rating is being measured. Now, the sampling and the criteria on the conformity, there are various methods are mentioned. All these criteria are not applicable for all the kind of fire resistance type of a material. Like for an example, take a boil test or bake test will not be applicable for your gel fill kind of a fire resistance glass or intumescent fire resistance glass. There has been a table has been created into a document which tell us like which performance testing parameter need to be followed as per the type of fire resistance glass, which was explained into a previous slides. Now, the packing, like what is the source of manufacturing, whether need to be it is mandatory to mention. These are the basic requirement which help to identify from where the glass is coming and when the glass is being manufactured, what type of a fire resistance glass it is being. Then the marking, E stand for the integrity and time for T stand for your time limit for which it shows the performance. Now, just coming to there are some slides. This is the part of a standard what I had explained you. Now I just try to explain you like how it is we are correlating with the product that is being marketed. So the product what we are manufacturing, it is in India, where we are doing this manufacturing of a gel fill kind of a product under the technology license of an AGC, where all the performance parameter are being measured on continuous basis to ensure that the life safety of the people is being ensured. So the product is a kind of a gel-filled kind of a glass where the two tempered heat-soaked glass is being used and a fire resistance gel is being put so that the fire performance will happen. Now, someone may ask, like, if there is a soda lime glass, how it works? So in initial phase, when it exposed to the fire, the inner layer of a glass will break and the gel inside it will get expand, and it will ensure that the outer layer will not collapse, and it will show the integrity performance. This glass, as we say, like, it will not allow flame, smoke and gas to pass through, and it will also restrict the passage of an heat. There are various performance parameters being made specifically for this category, but as per the manufacturer, this performance parameter may change. But the critical for this is a fire resistance property. What are the fire resistance property that particular glass or the manufacturing type of a glass is achieving? That need to be checked to validate it with the local bylaws or to with the NBC document. So I'm just showing you some small video to understand how this testing is happen for the system. Now I am talking about the system testing. Just a minute. I'm just playing a small video. So we are taking all this door and the glass and the hardware in a lab where we are installing it and checking the performance, where all the thermocouple are being put on the glass surface, the frame and the hardware. And the fire start as per the ISO 834 curve, where we are checking how the glass or the system performs. After exposure, the glass become an opaque. This is a gel kind of a glass where the inner layer of a glass breaks after 5 minutes, and it forms an opaque structure, opaque rigid structure, which holds the glass for the duration of 120 minutes or 60 minutes, depend upon the declaration by the glass manufacturer and the door manufacturer. After 10 minutes, you can see it's just an opaque white structure is there. I'm just skipping the video now. Now, coming to the fire testing and the certification. For testing and the certification, it is very important to check total system, because glass is one of the component into a system. The frame also need to be comply with the fire regulation requirement. Important thing what to check into a test report is like, and what your integrity, stability and the insulation and the radiation requirement, how much it is being specified into a test report. There are NABL labs available. There is the CBRI lab is also available in India. Apart from that, there are many private labs, almost like 18 private labs are available in India who are doing the fire testing, and there are some global labs also who does the testing as per the Indian standard as well as the European standard of the product. The glass what we are promoting is not only the fire resistance glass, but it is also an EPD verified glass, ROHS compliant, lead free glass that ensures that the client get an green building certification when they use a fire resistance glass along with the fire resistance material. This glass I'm not going into detail. Okay, well, these are the USP of a glass for the Pyrobelty, the product that what we are promoting. Various application of the glass is like this glass can be used for the internal partition, glazed doors, curtain wall application, the floor application or the skylight application, where the R rating is mandatory to check. For other application, a non-load bearing application, the load requirement is not required to be specified. Then your fire resistance window is another application where this fire resistance glass can be used. The NBC document talk about like where how much fire resistance rating of a glass and the system is required. In most of the cases is 120 minute of a fire rating, and for specifically for fire door, in addition to the 120 minute, they talk about the 20 minute requirement of an insulation. I hope like it will be updating into an NBC 2025 to the 30 minute of an insulation to further safeguard the life of the people. Now, how to select whether to go with an integrity or the integrity and radiation control? Because even though the standard says 120 minute, both the glass type of a glass meet the 120 minute requirement. However, in E category glass, the glass which is normally typically 5 mm to 10 mm or ceramic or borosilicate glass, a single layer glass is used, but which remain clear during the event of fire, but the heat radiation happening is so high that it will not safeguard the life of the people. This glass can be used where the property protection is important than the light protections, and maybe if the light protection is necessary in the particular building, maybe it can be used into a visual parallel application. And for the fully glazed door application, EW kind of a glass can be suggested, which will safeguard the life of the people. Now, visiting the standards. So there are multiple standards regulated with the fire resistance. For the metal door, wooden door, or the sliding metal door, it is IS 3614 is applicable. The testing standard for these doors are specified into an IS 17518, which is equivalent to your ISO 3008. For the fire rated glazed door and the partition application, IS 16947 and 16945 is applicable. The product specification standard for this is yet to be formed, and I believe the BIS committee is already working on formation of an standard for the door and the partition, glazed door and the partition. For the fire resistance glass, we had already came up with the specification standard IS 19328. And the testing standard for the glass is also specified into an IS 16938. Now, these are the typical application where the fire resistance glass is being used to enclose the staircase area or the internal staircase area, and various kind of an hardware being used, which is a fire rated, whether it is an unlatched door, latched door with the panic bar, or with the additional features like an opaque glass, or a higher size of a higher height of a glass like in 3 meter, or with some EM lock, access lock kind of a feature, which now the commercial buildings are also expecting to be supplied. This is a kind of a new thing which is now getting popular, which is a sliding door, where the fire, because of the high movement of a people inside the commercial offices, the customer is going for the sliding door application. But after fire, it acts as a partition. So wherever there is a sliding door is being suggested, we recommend to have an alternate route of exit, so that the people get an time to evacuate during the fire exit. So that's it from my side. If you have any question on the specifically on the standard, I will be happy to answer that.
Hello, sir. Am I audible?
You can push the button.
Yes, sir, you are audible.
Sir, here we have some queries, and for example, there is nothing mentioned about fire rated frames, what to be used, how to install the glass in them, and resistance against water sprinklers. And we are also having here D. Murli Mohan Garu, Director State Disaster Response and Fire Services, Andhra Pradesh. He has given significant inputs and has some queries. You can please answer them all.
If you want, I can also share the PPT, sir.
Yeah, I will share this PPT. First, I will answer the question. So, whether it is specified or not specified, the NBC is giving the guideline and the local bylaws, like the Andhra Pradesh bylaws also adopting the NBC requirement. And NBC talk about the fire resistance of 120 minute and 20 minute of an insulation for the fire resistance door requirement. So we do not require, like, whether the document when it is created, the tender document when it is created, if they are not specified, there is a law already available, there is a recommendation already given, and the people has to follow that requirement. And it is not only for for the purpose of compliance, but it is also for the life safety of the people and the fire officer who are going there in the event of the fire. So we have to follow like 120 minutes of an integrity or the partial radiation and the 20 minutes of an insulation for the fire resistance glazed door.
Sir has a presentation. He will share the presentation for the inputs which may be discussed.
Yes.
Sir, this is based on only our experience, not technically we are not discussing anything. So after going thorough with this code, we thought the following points are we added, not finding fault with anybody, but the following points which are next slides we can see. Next slide. So no requirements for the missing installation requirements in that code, sir. Requirements for fire rated frames, beads, gaskets, seals. See, the code mainly refers to the glass item, but in which frame it has to be fitted, that is not clearly mentioned, sir. Because if frame is not fire resistant, then there is no use of glass in fitting that frame, sir. So lack of anchorage, fixing hardware specifications, no compatibility requirements for glass and framing systems. As you said, the glass frame partitions, glass walls, IS 16945. Installation manuals and approved mock-up drawings. Test report must include fire rating, exposure site. These are all points are missing, sir. Please, if possible, you can add in that code, sir.
Okay, I just answer to your question, sir. I just go to my presentation. Just allow me time. I will show you the where it has been captured.
Yes, sir. Yes, sir.
So as I was talking, like, okay, fire resistance glass is one of the component into a glaze system or the glaze partition or the glaze door. When we tried to find, like when we was forming this standard, where we was only talking about the fire resistance glass, and in many of the cases the fire resistance system is being manufactured by the another party. So how to have an ISI marking for the fire resistance glass and how to ensure that the glass which is being manufactured is meeting the compliance requirement. So in order to standardize, because every manufacturer will have a different design, it may have the framing part I'm talking about, they may have a different design or different infill material, all this kind of a thing. So we had come up with the standard process. You can see into a testing document where the glass is being put, where we are using a standard steel box section and normal calcium silicate blocks to hold the glass. So here, apart from the system, this part will remain as it is for all the glass manufacturer, whether it is A, B, C or D. So all the glass manufacturer, when BIS is doing the audit, they will check the glass, they will audit the facility, and then they will check into a testing lab how the glass is performing, and then they are giving the declaration whether and they are allowing manufacturer whether to put E120, EW120 and EI30. So we are only talking about the glass standard. Okay, now coming to the framing part, as you said, like framing is a critical part for the system, and without the framing it will not make sense. So the framing standard, like as per standard is given 16947 and 16945, they talk about the testing for fire resistance glaze door and the fire resistance glaze partition. So it is clearly specified how the glass need to be tested along with in the system, which talk about the requirement. but as far as the product specification standard is required, like which kind of a gasket need to be used, how the frame need to be ideally manufactured, how the frame need to be checked. So that will come into an fire resistant glaze specification standard and which is yet to be formed. And BIS has already, I guess they had already initiated the discussion on this part. So there's two separate part we are talking. We are talking about fire resistance standard, and we are the separate for the fire resistance system standard. I hope I am able to answer your question, sir.
Yes, sir. Thank you, sir. Thank you. And one thing I can tell you, if fire is devastating, there is no glass or wood for that. So it will go on burnt like anything. You just go through the one. No, I have given link to a small fire accident that took place in Mumbai.
Are you talking about this component?
No, sir. Just what about the glass fire accidents in glass houses? Just one small videos.
No, I do not have. Okay, you are sharing, sir.
I am sharing, sir.
Okay.
presentation లో ఉందంట.
Name. Better link పెట్టాను.
ఒక్క నిమిషం.
Another. See, Goa fire is different. Goa fire is only wooden. There is no glass material. Yeah, this one. Okay.
There is a facade, there is a glass facade from where the flame is coming out.
See, it is burning like wood, not a glass like that. See, once it reaches the temperature, high temperatures, so that's why at least you should have, as you mentioned, at least 1 2 hours or 3 hours fire resistance.
Yes, I will explain you, sir. 2-3 per part here. What I can see, this is a curtain wall system and could be an aluminum fire resistance system. Aluminum system, not a fire resistance system. And the glass is being used as a soda lime glass, which could be a fire performance glass, not a fire resistance glass. So which will be about like a tempered glass. If you see the properties when it exposed to the fire, it lose its integrity within a 5 minute. So after 5 minutes, the glass collapse, and the glass itself, like as a property of a glass, it will not propagate the fire. Okay, it will when it exposed to the fire, it will melt. It will not help any propagation of an fire in any event, whether it is manufactured by any of the company, or even if you check the ignition properties of a glass, you will find that it is not contributing factor. And other like an aluminum also, which is having a melting point about 600 degrees Celsius, which also melt. So obviously, like there could be an alternative. What the NBC is suggesting, if one is going with a curtain wall system, aluminum curtain wall system, one has to have a water sprinkler system just inside it. And the water has to be come onto a complete glass panel so that it will not allow the increase of a temperature. This is first alternative. Second alternative is to use an fire resistance curtain wall system. But practically, when we see as a manufacturer, there are very rare people who goes because to the fire resistance curtain wall system because of the cost factor. So there is an okay, till the time the industry we develop with some solution which can help to prevent such an accident, we have to live with the current situation, sir.
Sir, yes, sir. Thank you, sir. Thank you for enlightening us. Sir.
This particular building fire, glass doesn't break into small pieces. Sir. It's burning like.
Yes. So that's what I am asking, that crystal structure should be there for any glasses, like our car and other glasses. Whenever it breaks, it will come into pieces. Like that, glass should be there. Otherwise, it will give. Even so many firemen during the fire accident have got injuries during the fire accident.
If glass catches fire, it doesn't break into small pieces.
No. No, this is not. Yes, I think this is not toughened glass. Toughened glass has that problem. Toughened, maybe, but it's not fire resistant.
Check once.
Yes, that it has to be checked because the fire resistant concept is now developing. No? So,
Any other questions from participants? Sir, I am Professor Devakumar, sir. What is the main business of this insulated layer glass? So is it fire protecting or just it stops the propagation of fire?
Okay, so the thing is, insulating glass, if you see the definition of a glass, we are putting some thermocouple on the unexposed surface of a glass, okay, and checking the temperature measurement. So this glass only will ensure that the heat radiation is not happening and allowing people to evacuate. Okay, first thing. The second thing, no glass result like no glass, whether it is a fire resistance and whether it is a non-fire resistance, it will not help in the propagation of a fire. It just melt based on the manufacturing type. Or the delay of the time is depend upon how we are what kind of a fire resistance glass is being used. So it just it just allows people to evacuate. It is not ensuring like 100% the people life will be will get protected. Like people has to act during the event of a fire. They have to move toward the exit and they have to safeguard their life. It is just providing an additional time for evacuation.
Okay. So to ascertain that quality of the insulation layer, what sort of tests we need to conduct?
So the test, when we are going with the system, the partition test, it is 16947 is given, and this test is being done at a third-party test lab. So we cannot do it into an real situation. It is being done at a test lab, and after we come up with the standard for the glazed door and partition, maybe we can have an audit and the certification from the BIS, and which will ensure like the glass which being manufactured consistently of the same quality, the same raw material is being used. So that audit and the marking will happen once the standard of a complete system come into place. As of now, we just came up with the standard for the glass, and with that standard we will be checking, and the BIS will be auditing the plant. They will be validating, like as Vivek sir had explained in the last session, like the procedure of like how the validation happen, how the QCO will work. And for that, one need to have the document, and that document is like for fire resistance glass is 19328.
Okay. Thank you, sir. Thank you.
Thank you, Tushar sir, for giving a presentation on the standard. I hope it is a very useful session to all the participants also. Thank you for joining through virtual mode. With this, we will conclude the session, and still if anyone have any doubts, they can raise. Otherwise, we'll conclude the session and it will be followed by a lunch. Okay.
Before vote of thanks, our head stream Sajini Patnala garu is present. Mementos to our distinguished guests. Sri D. Murali Mohan garu.
And on behalf of APIIC, also small compliment for the speakers. Thank you.
Professor Devakumar garu.
Thank you.
Sri Narasimha Rao garu. Dr. Ramanaya Mallu garu.
Main aspect.
With mementos presented, I request 3D Rajgopal garu, Scientist Day, Joint Director for
Thank you, madam. May you present the vote of thanks.
Laminated
Thank
points.
something with the Vijayawada branch. So taken the initiative for this program, so that this program will be conducted. Then I thank Dr. G. Murali Mohan, Director State Disaster Response and Fire Services, for raising all the clarifications and discussing it at the end. I thank Dr. D. Murali Mohan because these kind of comments will be taken up to the respective sectional committees and district council. Then I thank Professor Devakumar for his enlightening of sustainable development goals and glass standards essential for the commercial use. And also now I thank Vijayawada Reddy, Scientist P and Deputy Director, for presenting an overview of the presentation. Then I thank Dr. Ramanaya Nallu, Professor of Mechanical Engineering, Andhra University, Visakhapatnam, for his reporting of glass manufacturing process. And then finally I thank Mr. Tushar Zope for detailing about fire resistant glasses. I thank Sneha and Zubeda for organizing, and also System for organizing this program. And all the participants, I thank them all for coming and gracing this occasion. Thank you very much. Thank you very much all.
Yeah.
Thank you, sir, for the comprehensive vote of thanks. With immense pride, let us all rise for the national anthem. Janaganamana.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा बंगा हिमाचल यमुना गंगा उच्चल जलधि तरंगा शुभ नामे जागे तव शुभाशिष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे गण मन.
Thank you. Thank you so much.
గ్యాస్ లాగా లిక్విడ్గా గ్యాస్ లాగా కలర్ ఏమో అది దాన్ని